Good morning. This week, week 6, we are going to be discussing volume a little bit uh, easier than, say, the surface area that we were doing 2 weeks ago, although a lot of the terminology is still going to be the same. You are still going to be looking for the base area, but now the height is going to become more important. Back when we were doing surface area, you had a lot of slant height, and you had to make the distinction. You had to use some right triangles to find some lengths. Still going to be using some right triangles in the sense that some of our bases are going to be regular figures like regular hexagons or regular triangles. So you're still going to have to use that, find the apothem, and then find your perimeters just like you were doing with that. But for the most part, volume is going to be a little bit easier. Again, identifying the base is one of the easiest things to do. Remember that the bases are going to be congruent and they're going to be parallel. So if you look at problem number 1, we have a right triangular prism. Remember, it's named by its base, so it's a right triangle. So if you look, or it's not actually a right triangle, but this is a right triangular prism. So if you look at the base, you can see that it's a triangle. And so we need to find the base area, which is going to be represented by the capital B in the volume formula. So volume is going to be equal to the base area times the height of the actual prism. So if you look at this, the first thing we need to do is figure out what the base area is. Well, it's a triangle. The area for a triangle is 1/2 base times the height of the triangle. So looking at that, we got to figure out what the height of the triangle is. So we're going to say that the base is actually 10. And then we have to figure out what the height of that triangle is. So we're going to have an equilateral triangle here, 10, 6, and 6. Well, to do that, we're going to have to draw in an altitude, which is the height. So that's going to be our h of the triangle. All right, so then how do we figure out what that value is? Well, you got Pythagorean theorem. This is going to bisect, if you remember. So that's 5. So we've got 6 squared is going to be equal to 5 squared plus h squared. So we got 36 is equal to 25 plus h squared. H squared is going to be equal to 11. So I'm kind of running out of space there. H is going to be equal to the square root of 11. And that's what we're going to put in here. All right, so if I multiply all that out, 1/2 times 10 is 5. So the base area is going to be 5 times the square root of 11. So that's what we're going to substitute in for B. And then our actual height of the prism is going to be 14. Then we just plug those values in. 5 square root of 11 times 14, and that's going to be equal to 70 times the square root of 11. And if you put that in the calculator, what you're going to end up with is 232.16. So prisms, pretty simple. Finding the base area is the hard part. Most of the time the height is going to be given to you. Base area times the height. And the other thing you're going to find in this worksheet is a cylinder. Same thing. Volume is going to be equal to the base area times the height. The difference here is your base area is going to be a circle, pi r squared, which means you're going to have to determine the radius. Okay, so in this problem, they tell you the circumference is equal to p times pi. Remember, circumference is equal to 2 pi r. So then p times pi is going to be equal to 2 pi r. So we eliminate this, and p is going to be equal to 2r. and then you would substitute and mix those things in, finding your area. Pretty much the same as the rest of them. So go ahead and give those an opportunity. Number 7 is a little bit more challenging. Remember that on problem number 6, you're going to find the cylinder and then take half the volume and add it to the rectangular prism. If you have any questions, remember on Thursday, I will be doing the Google Meets for each one of your geometry classes. Good luck.